For our first example, we are told that funding is organized for a new scholarship and it receives 16 equally qualified applicants. The selection committee plans to accept 4 of the applicants where each gets equal support. How many different combinations of 4 applicants can be selected from the 16 total? So here, ignoring the fact that I wrote combinations in there, what we should be able to tell is that because the funding is all the same, the order in which they're selected doesn't matter. The first person picked gets no more support than the fourth, gets no more support than the second, gets no more support than the third. So, as order doesn't matter, we use combinations, which means that we are taking n equals 16 options and choosing r equals 4 of them. 16 C4, using that notation. Again, not really the most instructive or obvious notation, but it's the one the book uses, so it's the one I'm going to try to use as much as possible. But really, this value is 16 factorial over 16 minus 4 factorial times 4 factorial, as we don't care about the other 12, and we don't care about the order of the 4, but we do have 16 total things. Now, from here, we can do a little bit of algebra to simplify this down just a bit, where here we can get 16 times 15 times 14 times 13 times 12 factorial over 12 factorial for that 16 minus 4, and another 4 factorial. Those two will cancel out, and what we're left with then is 16 times 15 times 14 times 13 over 4, I'll actually write that bottom part out too, times 3 times 2 times 1, which, after a bit more algebra, a bit more work, or if you prefer running this type of thing on the calculator to make it do all of the heavy lifting here, long and short of it is, what we will end up with is a value of 1,820 ways for the 4 recipients to be chosen out of the 16 applicants.